Steve, hydrogen.
Yeah.
There's a lot of it.
Yeah.
Maybe not on Earth, but
Right.
the universe has a lot of hydrogen. So should we pick this as the next alternative fuel source, or should we stick with electricity? What's happening?
Well, the choice isn't between hydrogen and electricity. It's using hydrogen as a way of making electricity, right? Because like hydrogen fuel cell cars are electric cars. They're just the power source is the hydrogen fuel cell versus a battery.
Right. Okay.
But the question is, is hydrogen, first of all, is it a useful source of energy? Is it a useful energy storage medium? So while hydrogen is the most abundant element in the universe, it's not a good source of energy because there isn't a lot of free hydrogen on the Earth.
You have to make it.
At least that we know of, right. Hydrogen is mostly bound up in other molecules, mostly water and fossil fuels, like natural gas, methane, et cetera, biological stuff. So if we look at, for example, hydrogen bound up in water, you could electrolyze that water to split the two hydrogens off from the oxygen molecule, oxygen atom, and then but you have to put energy into it, right? Then you could burn that hydrogen back with oxygen, you get water as a byproduct, and you get the energy back out. But of course, every time you make a conversion,
you lose
energy. So we call the round trip? What's the round trip efficiency of that process? Unfortunately, for hydrogen, it's not very good. You only get up to maybe 60%. Total round trip efficiency when you do that.
So there is no thing on Earth that's spewing out hydrogen that we can
So
collect.
the one caveat to that is there is some natural pockets of hydrogen in the ground, and because what can happen is you can have water next to hot rocks, under the Earth that can get, hydrolyzed, and you get some free hydrogen leaking away from that. But because it's a light element, it tends to seep through the Earth and off into space, right? But the question is, does enough of it get trapped in pockets because of hard enough rock that we might have actual free hydrogen under the ground as a source of hydrogen? So there are some scientists who think that there might be significant sources of hydrogen under there. That's a big if, though, at this point in time.
And it sounds fantastically dangerous.
Well, it's highly combustible, but we take natural gas out of the ground and pump that to our homes and light it. So that sounds fantastically dangerous as well.
Yeah, you're right.
This is really the big difference is that hydrogen, because it is the lightest element, right? It is the first element. It seeps into things very easily. It can get into metal. If you
wait, hydrogen is into metal. It's not into
to ska
plastic
or
rock,
jazz or freeform jazz or whatever. But it's called hydrogen embrittlement. Like it could actually break down the containers that it's held in.
Like what kind of any kind of metal?
Yeah, pretty much. So you have to coat it with impervious things, which is fine. That works, but it adds expense and weight and everything to any container. Also, it has the highest energy density because it's the lightest element, but it's a gas, right? That's the problem because there's not a lot of gas per volume unless you store it under a lot of pressure.
Then it can liquefy, right?
Well, that's different. Liquefying is about lowering the temperature. Well, it's a combination of things. You've seen those graphs where it's like temperature and pressure, and here it's a solid, here it's a gas, here it's a liquid. You have to see where you are on the pressure temperature map. But basically, you under even high pressure, you need to make it really cold in order to get it to be a liquid. But most of the time that we're using hydrogen now for everyday use. For rockets, it's liquid hydrogen, right? And so that we use the cooled version. But for a hydrogen fuel cell car, for example, it's just hydrogen gas under pressure.
Yeah.
And so that is also sort of a technical challenge to it. So right now, hydrogen is not a source of energy because there's not a lot of free hydrogen that we know of that we can get access to on the Earth. That may change if we find geological deposits of hydrogen, but that's a big question mark at this point in time. So how is it as an energy storage medium? You have hydrogen, you can store it as a compressed gas or even as liquid hydrogen, and then you can then burn it to atmospheric oxygen to make energy, right? To make electricity to run a car or to run your house or heat your home or whatever. It's also very useful in industrial processes, and most hydrogen that's made on the planet today is used not for hydrogen fuel cells, but for industry, for making things like ammonia for fertilizer.
Like chemically, right?
Yeah,
That's what you're saying?
Yeah,
Okay.
making chemicals. It's used in, you could use it to make steel. You could use it to make a lot of high energy compounds, right? Because it's basically a high energy element.
Well, what would it look like, though, if we did want to use it for transportation?
Yeah.
Right, as a battery.
That's the big question.
I mean,
Yeah.
infrastructure is a big concern.
Yeah, so we could look at it in a few ways, right? One is infrastructure. One is just, well, how are the vehicles themselves? And another way to look at it is say, what would be the net effect for global warming, right? For our carbon footprint.
Mm-hmm.
So let's look at the vehicles themselves. Hydrogen fuel cell cars are just fine, actually. Now it's a maturing technology. 20 years ago, when we first were experiencing the coming hydrogen economy, they thought they were going to invent some kind of substance that would like bind the hydrogen so it could be safe.
In a solid, right?
Yeah, like in a solid, and that never really worked out. So instead, we just compress it. It's just the old technology. We put it in a tank and we compress it in a tank. But over the last 20 years, the technology for making those tanks has improved. We have more advanced material science now. You can use like carbon fiber material that's light and strong. So you can make a car that has, say, 2 or 3 hydrogen tanks, and that it can have a range of 300, 400 miles, which is fine.
But didn't we learn our lesson with the Hindenburg?
Yeah.
You know?
Well, yeah, you are driving around a vehicle with compressed hydrogen gas. So, yes.
Like if
there's a
that ever
safety
went off,
issue.
I know it would be very uncommon, but if it ever did go off, you would be obliterated.
Yeah, I mean, we have the same problem with, or similar problem with like lithium-ion batteries can catch on fire and have these, runaway reactions. So yeah, I know technology is perfectly safe, and so far they seem to be pretty safe. But again, with hydrogen fuel cell cars, there's such a tiny fraction of the cars that are out there in the world today, a fraction of a percent, that when we think about scaling it up to a degree where it like actually is taking a chunk out of our carbon footprint, then all these questions, like even a statistically rare accident could still happen a lot. Like,
yeah.
And again, it wouldn't be a lot worse than just your car catching on fire, right? If that tank blows.
Imagine if it happened in a garage. Like a
right.
parking garage.
So
with
that's
dozens
something
of
that
cars.
engineers have to think about, right? It's got to be really, really safe if this is going to be a mass production kind of thing.
Yeah.
But you could buy a hydrogen fuel cell car today. They have good mileage. You could fill them up in a couple of minutes at a station that has hydrogen, and they're powerful. It's a good driving experience, right? So these are fine as in terms of the individual
But that's
cars.
another thing, though. You just said you can fill them up.
Yeah.
We don't have the distribution. We don't.
So it's potentially an advantage over battery electric vehicles because it's faster refueling than recharging your car. But now you're clicking over to the infrastructure issue.
Right. Okay.
And that's where hydrogen is at a massive disadvantage to, let's say, battery electric vehicles. We don't have a hydrogen infrastructure right now. There's very few places where you could fill up your car. And it'd be a massive infrastructure project to build that out. So for every step of the way, producing the hydrogen, storing the hydrogen, transporting the hydrogen, distributing the hydrogen to the end user, that infrastructure doesn't exist. It would probably take a couple of decades, to really build it out.
And trillions of dollars.
And trillions of dollars. It would be a massive project. Now, if it was a good idea, you could say that's worthwhile investment.
Yeah.
And we're definitely going to have to build out our infrastructure for battery electric vehicles as well. I mean, that's a lot of more electricity we're going to have to be generating and distributing. We're going to have to upgrade the grid, which is going to cost trillions of dollars.
But electricity right now is going to almost everybody's house.
Yeah.
Right? It's already inside the backbone of our society.
Right.
And it doesn't explode.
Right. And I have an electric vehicle, and I was very easily able to put a charger in my garage. There you go. I could charge my car in my own garage.
And there's your fuel source.
Right. And there's my fuel source. So let's talk about production of hydrogen. This is the big issue. 96% of the hydrogen we're using on the Earth today is gray or worse hydrogen. It's made from fossil fuels, right? So there's a color coding system for hydrogen. The brown and black are made from coal. Gray is made from natural gas, and blue is made from natural gas. But there's some carbon capture to reduce its carbon footprint.
And blue's the best, right?
No. Green is the best. Blue is also
It's on the bad side.
it's really bad actually.
Okay.
So for the gray hydrogen, which is making it from say methane gas, from natural gas, it's actually worse than just burning the natural gas directly.
Wow.
It's actually worse. You're better off in terms of the carbon footprint just burning the natural gas. Because then if you're going to store it as, strip the hydrogen and then burn the hydrogen, you lose a loss of efficiency. If you do all the calculations, you're actually worse off. The blue hydrogen is actually only about 20%, 15 to 20% better than the gray hydrogen, and it's still worse, really, than just burning the natural gas directly. And that's where we are today. That's 96% of our hydrogen.
So it doesn't seem like it's...
And so if you buy a hydrogen fuel cell car today, you are hurting the environment. It's not better for the environment because until we have an infrastructure of green hydrogen, it's not good for the planet. What's green hydrogen? That's hydrogen that's made by splitting water is one example. There's even different colors, like you might assign different colors to different methods of producing the hydrogen. But if we just say green is made from renewable sources, then like wind and solar, right? And so you have a solar panel, produces electricity, splits water into hydrogen and oxygen. You store the hydrogen. There's your green hydrogen. So that's it has whatever the carbon footprint is of the solar panels, which is not zero, but it's pretty much as low as it gets. So that's the best we could do. But again, we're making a less than a percent or whatever of our hydrogen is the so-called green hydrogen. So the question is, how could we scale that up?
Why even bother, though?
Why even bother? That's what people are asking. Why don't we just use that electricity to charge your car or whatever? But then that gets to the comparison of like what's more efficient, and we'll get there. But there's a lot of comparisons that we could make. So that would require a lot of infrastructure. That we would have to almost double our current energy production, just to make enough hydrogen to fuel our fleet of cars. That's massive, just to do that. So there's lots of issues with that from an infrastructure point of view. It would be very, very difficult. Perhaps the best way to make hydrogen would be through nuclear power, because just the amount of energy we could make from the nuclear power plants on the amount of land, in terms of, that's the other issue, like how much space are we going to need to make all this hydrogen? You could probably make the most with nuclear power. And some of the newer nuclear power plant designs produce hydrogen as a byproduct. It's like you're not using the electricity to make hydrogen. It's produced in the nuclear process that's making the electricity to begin with. So we could have a nuclear power plant that's making hydrogen as a byproduct.
But enough, how much would it
take?
Well,
yeah, but it depends on how many of these plants we make, and are we using this kind? And then you could also use the electricity to make more hydrogen if, whatever works out to our needs. But of course, that's a separate video on nuclear power, because there's a lot of controversy about the cost, basically is what it comes down to. It's still an expensive form of electricity. And at least for now, if you're talking about just the cost competitiveness, green hydrogen or hydrogen from nuclear can't compete with gray hydrogen or even blue hydrogen from fossil fuels. So we're basically saying, it's going to cost a lot more money for your hydrogen if you want it to be green, because the infrastructure is not there to make it cost effective at this point in time.
Right. So then when you compare all of that to electricity, where does it stand? So here's the big thing. Battery electric vehicles are very efficient. Those batteries, in terms of like the round trip efficiency and also like the so-called well-to-wheel efficiency, like how much of the energy that's going into the whole system is going to accelerating those wheels against the road, right? For battery electric vehicles, you can get up to 80, 90%, if you're using the regenerative braking and you're doing all the things that you need to be doing. It's very good. For hydrogen fuel cell cars, it's 25 to 35%. It's less than half. So you're using twice as much energy per mile with hydrogen than you are with a battery. And so that may be the ultimate deal killer for hydrogen fuel cell as a car, if using for your car. Then we can say, okay, there's lots of issues in terms of infrastructure. Like, but we're having problems like sourcing all the lithium and cobalt and nickel for batteries. And that's true. And that's an issue that we're going to need to solve if we're going to turn our fleet over in the next 20 or 30 years to all battery. And so some people are saying, well, we should maybe do some hydrogen because we don't have the raw materials for the batteries. It's like, but the problem with that is that
the technology to make the hydrogen, and also in the hydrogen fuel cells, uses platinum and iridium in like the membranes, the ion membranes that separate out the hydrogen from the oxygen.
That's
platinum
even more rare, right?
And iridium, they're even worse. They're even more rare and more small. So, and there isn't enough. There isn't enough on the planet in order to have like a fleet of hydrogen fuel cell cars and the hydrogen fuel economy that, infrastructure that we would need. So, but there's research in the pipeline that replaces the platinum with iron, which would be great, but it's not in production yet. So it's, again, you're counting on a new technology, which is possible, but we can't place our bets on it yet. So, this is just sort of hitting the highlights of sort of making the comparison there. So if we say, what are the prospects for like a battery electric vehicle versus a hydrogen fuel cell vehicle in the future? It's not looking good for hydrogen.
Not at all.
It's going to take a long time to develop the infrastructure. We still don't know how we're going to like source all the platinum and iridium that we need. The efficiency is not there. Hydrogen is really hard, gas to deal with. So there's a lot of problems there. The other thing is, my personal belief is that it's going to take us, by the time we would really get a hydrogen infrastructure up and running, the battery technology is getting so much better, so much more quickly. It's just going to kick the ass out of hydrogen. Yeah. But here's one, I think, little saving grace for hydrogen for transportation. I think it's what we want to do is, first of all, if we're going to be making a bunch of green hydrogen, we need to use that in industry. We need to replace all that gray, brown, and black hydrogen in industry, not burning it for our cars, which we can use batteries for. But there is, in transportation, there is this one niche where hydrogen might eclipse batteries, and that's in long-haul vehicles. Because here's the thing, hydrogen and batteries scale up differently in terms of the weight per mileage that you get. Cars get less and less efficient. Battery electric vehicles get less and less efficient when you try to get more and more range, because the batteries get heavier and heavier. Right. And that weight, you have to drag that weight around, and that creates more inefficiency. Whereas the hydrogen gets heavier too because of the tanks themselves, but it doesn't scale the same way. Like you can have bigger tanks and you get, or compress the hydrogen more or whatever, you get more. The hydrogen itself is negligible. It's like a few kilograms, 6-7 kilograms of hydrogen. It's nothing. But it's like the 100 kilograms to 200 kilograms for the tanks. That's where all the weight comes in. But it scales differently. And so as you get to longer and longer haul vehicles, 500 miles, 1,000-mile range, they start to get more efficient than battery electric vehicles.
So then maybe tractor trailers?
So that's where I think it's going to be the niche, right? The long-haul trucking is where hydrogen will be useful. And also think about this. They have predetermined routes. So you only have to build the hydrogen refueling stations at truck stops. You don't need to put them everywhere. Right. So the infrastructure is a lot easier too. So I think that's probably going to happen. We'll have hydrogen fuel cells for trucks, maybe for trains as well. And then we'll have battery electric vehicles for everything smaller than that, all of the passenger cars, all the other stuff. That's what I think is probably going to happen. I think that's where, if you balance out all the pluses and minuses of the two competing technologies, I think that's where we are. We've talked about on our show, and we know that they're already producing batteries that are twice as energy dense as the ones that are in cars now. Right, yeah. And it's only going to be a few years, 3 or 4 years, before they're going to be in cars. And then maybe in 10 years, we're going to have twice again as the energy density. Just we're still on that steep part of the curve with battery technology. We're not anywhere near, like even going to the silicon anodes, the theoretical limit there is 10 times more energy dense as the batteries we have now. Yeah, that's significant. Yeah, so I don't know if we're going to be able to get all the way there, but even if we get most of the way there, it's going to blow away hydrogen. Right.
Good. I'm glad to hear it. Yeah. Because I don't want a chain reaction of explosions on the highway.
Right. Yeah. I mean, the safety issue, I have to look more deeply into that, because it's so far, like just for the cars that are on the road right now, I don't think it's a big issue. Yeah. But again, we have to think, if you're saying we're going to have billions of these things on the roads in 10 or 20 years, well, where's all the platinum coming from? What are these statistical safety issues? How much pipeline are we going to have to be laying that are rated for hydrogen? Like, you can't use regular pipes. Again, the hydrogen is very leaky and very corrosive, and so you need special pipes if you're going to be piping hydrogen around, and that's just infrastructure we don't have.
My only mental comparison I have is natural gas, and I've seen images of when a natural gas
did a house blow up? Yeah,
the house doesn't just blow up; it turns to matchsticks.
Yeah, I know. I've seen that.
It shreds the house.
Seen those videos. Yeah.
So, and hydrogen is even more explosive than that. So I don't know. I haven't seen anybody talk directly about the safety issues of having hydrogen be everywhere.
It's a concern, which is why 20 years ago we didn't just go instantly to we're just going to have it compressed in tanks. They were hoping for a safer storage medium, but just never materialized. Yeah. So okay, I guess we have to compress it in tanks. That's we're going to use that old technology. That's all we got. And we can get the material we're making them out of is better, and it does help. It is definitely a huge help. They are stronger and safer for that reason and lighter. And maybe there'll be a material science breakthrough where we could make these awesome tanks where we can get all kinds of pressure and they're really strong. Who knows? But again, we can't play the what if game. We're going to tackle global warming. We want to reduce our carbon footprint. We want to know what can we do with the technology we have now and with the incremental advances we know are coming, like they are in the pipeline, they are happening, versus what if we make this discovery, or what if that happens, we can't count on the what if.
Right now, so the final word is hydrogen might be number one on the periodic table, but it is not number one as an energy source here on Earth.
It is definitely not as an energy source. As an energy storage medium, I think batteries are winning the competition right now for most applications, with an asterisk for maybe long-haul vehicles might be where it's useful for transportation. Otherwise, there's a lot of industrial uses of hydrogen, and that's where we should be making green hydrogen and putting it into industry.